students, today we will start the very interesting topic, that is gravitation. Gravitation is a name given to the force of attraction, so that every body in the universe attracts the every other body. Gravitational force is the weakest force among the all fundamental forces here. So there are the four fundamental forces we can observe here, that is gravitational force, electrostatic force, weak nuclear force, strong nuclear force. Among these four fundamental forces, gravitational force is the weakest force among all these four fundamental forces. Being the weakest force among the four fundamental forces here, it will play a very important role in initiating the births of the stars, and it will control the entire structure of the universe. So first law based on this gravitational force or the force of attraction is discovered by the scientist Newton. So he stated the law. That law is named after his discovery, that is called as Newton's law of gravitation. What law suggests here? Every body in the universe attracts every other body. If you consider the two bodies here, say whose masses are m1 and m2 here. So they are kept at a certain distance r apart. So force of attraction is taking place between these two bodies here from the center. So gravitational force is also called as a central force because it is attraction force. It is force of attraction. So the force of attraction or gravitational force is taking place between the two bodies whose masses we already know here, m1 and m2. The law states, the Newton's law of gravitation states here, gravitational force of attraction between the two bodies is directly proportional to the product of their masses. And the again same gravitational force is inversely proportional to the square of the distance between considered two bodies here. So let me repeat here. If you consider the two bodies, what the law states here, every body in the universe attracts every other body. So here we have taken the two bodies whose masses already we know, m1 and m2 respectively. Both are kept a certain distance r here. So force of attraction is taking place between these two bodies from the center of the body place. So gravitational force is also called as a central force. Then according to the Newton's law of gravitation, what law states here, every body in the universe attracts every other body. So that is directly proportional to the product of the two masses, two bodies we have already considered, and inversely proportional to the square of the distance between them. So inversely proportional to the square of the distance between them. So incidentally we can write here directly, the gravitational force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Now you can able to see here proportionality is there. Now after proportionality removed, I used to give it a proportionality constant here, that is G n1 n2 divided by r square here. So what is G here? G is nothing but the gravitational constant. So what is this gravitational constant? So Newton's law states here, proportional means force of attraction or a gravitational force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. If you remove the proportionality constant, we will get it here. Once again I will write it here. So product of two masses and inversely proportional to the square of the distance between them. Then F is equal to G n1 n2 by r square here. So G is called as a proportionality constant, or else we can say that it is a gravitational constant it is. So gravitational constant. What is this gravitational constant? So it has some value. That is, many scientists have did the experiments and they have found out its value. That is around 6.67 into 10 to the power minus 11 as a unit. So we will discuss how the unit will also come, how we can calculate the x value. Experimentally we can also determine here. So they did the experiment and they have presently accepted this value as a universal constant, means universal gravitational constant. This value will be remains the same throughout the universe. So how it can be calculated? That is experimentally determination of gravitational constant. So we will take one experimental idea. For the experimental setup, we need two bodies here. Means one will be the big sphere, another one will be the smaller sphere here. And we need a rigid support to suspend over here. And bar and the rigid support. Now I will draw the diagram here. So we need a rigid support. We call it as it is a rigid body. Rigid body. We'll take a wire here, fine wire. And over here, bar will be there, two ends. So we need two ends of the bar here. On that, we'll take it here, B and A. Two ends of the bar. And that length will be measured in terms of L. Right? And these are the small sphere. We need two kind of sphere here. Small sphere. And we have to consider the big sphere here, which is certain distance from the small sphere, but in opposite. So, certain distance R, this will be the bigger, whose masses will be considered as a M2, and smaller sphere's masses will be considered as a M1. So, see here, the big mass on another end of the bar I have taken this side. Okay, whose masses will be again M2. So, we will get down here, and this will be the smaller one. So, experimental setup. How we have to set up the experiment to calculate the gravitational constant value, which can be considered as a universally, that value is remains same. So, we need one rigid body here, one fine wire is there here, which is attached. So, two ends of the bar. So, this is the one bar having the two ends. On the two ends, small sphere will be attached, whose masses will be taken as an M1 here. And with the certain distance, big sphere will be placed. That is, whose masses will be taken as an M2 here. And this bar, two ends of the bar will be suspended from the rigid support with a fine wire here. Now, force of attraction is taking place between the smaller sphere and the big sphere here. So, gravitational force between these two bodies will be taking place in a same equal magnitude but opposite to the direction of each side. See here also, the big sphere is very nearer to the smaller sphere. So, it attracts the smaller spheres to it, but opposite. So, here also big sphere is there, that will attract the smaller spheres. Means force of attraction is taking place between these two, smaller sphere and the bigger sphere. Here also the force of attraction or a gravitational force is taking place. So, bigger spheres attracting the smaller spheres here, that is towards it. But they are in opposite direction. So, this bigger spheres are attracting in this direction, bigger sphere attracted the smaller sphere here in this direction. Means gravitational force takes place equal in magnitude but opposite in direction. So, continuously this gravitational force is executing on both the ends of the bar and between both the bodies here. What it will happen? It will start rotating. Bar will start rotating. So, when the force of attraction is taking place between two ends of the bar here, so that will start rotating over the wire. So, as an axis. So, it will be start rotating. So, here when gravitational force is taking place between the bigger sphere and the smaller sphere, actually the bigger sphere is very nearer to the smaller sphere. Bigger sphere attracts the smaller spheres with the force of attraction. On both the ends of the bar it is taking place. With this force, with the resultant of both the gravitational force here, gravitational torque is developing on the So what is this? Gravitational torque. Gravitational torque. So what is this torque? Torque is nothing but the turning effect of the force. So force is taking place, whether it is whatever kind of the force. Now here we are considering the gravitational force, because our force of attraction is taking place between the two bodies here. One is a bigger one and the one is a smaller one. But it is not only one end of the bar, both the ends, two ends of the bar. Such a type of experimental setup is arranged here. So both the side of the bar, gravitational force is taking place. So continuously this force is also taking place, this force is also taking place. So it is started, bar is started rotating on the wire as it is an axis. So this continuously taking place, the gravitational force, resultant gravitational force between these two bodies on both the ends of the bar here. Gravitational torque is developed in the bar. So gravitational torque is developed in the bar. Means this force is turning. Turning effect of the force is called torque. So that's why the force is turning up because of gravitational forces. It is called as a gravitational torque. So it is started slowly rotating. As the wire is get twisted here, so one more force is taking place. So as wire is twisted, so how it is twisted? So it is rotating, it is moving and twisting, twisting, twisting. So there, how many twists are taking place? No, there one more force will be, and one more torque is developed, that is restoring torque. So that is restoring torque. What is this restoring torque again? The force, gravitational force is developed on the bar because both the ends of the bar masses are suspended in such a way that gravitational force is taking place between them, and that is resultant of their gravitational force. Gravitational torque is developed in the bar, and that will start rotating. The bar will start rotating on the wire as an axis. It will take as an axis and it will start rotating. As a twisted takings on the wire here, the one more torque is developed on the wire, that is restoring torque, which opposes the gravitational torque which is already developing in the bar here. So that is again opposes the gravitational torque. So wire will get twisted until that restoring torque and gravitational torque becomes equal to each other. Means a certain position it will come where both the torque will be equilibrium position. So it will be equal to each other. At such moment, until that such moment, the wire will get twisted. So later what it will happen is, we'll discuss the force of attraction between the two bodies. So according to the Newton's law, what is that? M1 and M2 raised to r square. So M1 is a small body, M2 is a bigger body, and r is a distance between them. Now what it will happen here? G, M1, M2 and r square. So gravitational torque is also called as a deflecting torque. So this is a symbol for torque. Symbol for torque. So gravitational torque is also called it as a deflecting torque. So it will be taken as a deflecting. So that is what is equal to the product of force, gravitational force and length of the bar, because gravitational torque is developed in the bar just because of gravitational force executing on between the two bodies here. So that gravitational torque is equal to the product of gravitational force and length of the bar. So what is the gravitational force here? G M1 and M2 by R square into L. So this is the gravitational torque. Gravitational torque. Once again I will write it here. Product of gravitational force and length. Force we know according to the Newton's law of gravitation, F is equal to G M1 M2 by R square. So product of their masses are inversely proportional to the square of the distance between them. So deflecting torque, that is equal to the product of gravitational force and length of the bar. Because of gravitational torque is developed in the bar here because of gravitational force taking place between the two bodies which is attached to two ends of the bar here. Then torque, restoring torque. What is restoring torque? Again symbol is there. I will just write it here. Restoring torque, that is equal to the product of torque per unit twist. So how many times wire will get twisted? No, that many times torque is developed. That is restoring torque. Restoring torque, the torque as per unit twist and angle of twist. So how many angle of twist is there? So theta, C will be taken it as a torque per unit twist. Per unit twist. And theta will be the angle of twist. So restoring twist will be taken product of torque per unit twist and angle of twist. Now let me once again repeat here. As the gravitational torque is developed because of gravitational force is taking place between the two bodies here. So M1 will be the smaller sphere and M2 will be the bigger sphere. On both the end of the bar, two smaller spheres whose masses M1 is attached and very nearer to the small sphere, big sphere will be attached whose masses will be M2. And now the force of attraction is taking place. Means bigger spheres attracts the smaller one on both the end of the bar here. Attracting smaller sphere is attracting towards the bigger one. That force develops the gravitational torque in the bar. So it starts rotating on the wire as an axis. Now once gravitational torque is developed in the bar, so torque you know that is turning effect of the force. Force, what kind of force it is? Gravitational force. As continuously is taking place between two bodies, so gravitational turning effect of force, it is gravitational torque is developed in the bar. There must be some another torque which opposes the gravitational torque because bar is not suspended free. It is suspended with a rigid support with a fine wire. So it will start rotating. Wire get twisted here. So twisting of this wire will get a restoring torque. So that restoring torque opposes the gravitational torque. How many times the twist will take place in the wire? That many times restoring force will opposes the gravitational force. Gravitational torque here. So this process is taking place until both the restoring torque on wire and gravitational torque in the bar becomes equal to each other. Now, according to the law of gravitation here, the force of attraction is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So, as we know here, tau will be the symbol for torque. Now, C will be torque per unit twist, means how many times wire will get twisted. So, that is torque per unit twist. Theta is what? Angle of twist. How many? Angle of twist will be there. So that is there here. Then gravitational torque is also called as a deflecting torque. So that is equal to product of the gravitational force and length of the bar here. Then restoring torque, that is equal to product of the called as equilibrium position. So this position will be the equilibrium position. Equilibrium position. At that position, what it will happen? So toe deflecting value is how much it is? G m1 m2 by r square into L, that is equal to torque restoring, that is C and theta. C means what? Torque per unit twist. Theta is an angle of twisting. Now what it will happen? G is equal to C, torque per unit twist, angle of twist into r square divided by m1 m2 L. So by knowing these values in this experiment, what is that? C is a torque per unit twist, theta is the angle of twist, r is what distance between the two masses we have considered here. One is a big sphere, another one is a smaller one, m1 and m2, distance between them, and m1 and m2 will be the masses of the considered body and L will be the length of the bar. By knowing all these values, we can able to find out the gravitational constant value that is presently accepted. It is the experiment and they have presently accepted the value 6.67 into 10 to the power minus 11 Newton meter square and per kg square. I'll come to the point how the unit will be got. With the help of again gravitational law of gravitation, Newton's law of gravitation only, we'll get to know that how we get the unit of the gravitational constant. So this value will be considered as a universally gravitational value will be considered as the same. So this value will be same throughout inverse. Now next comes to the point how we can calculate the unit of the gravitational constant. Now again, the gravitational forces are directly proportional to the m1 product of their masses and inversely proportional to the square of the distance between them. So F is G m1 m2 divided by r square. So G is equal to m1 m2 F r square by m1 and m2. Now first we will move towards the SI unit. How we can represent the gravitational constant in SI. Now force will be calculated in SI system Newton. Distance r will be measured in terms of meter and m1, m2 will be measured in terms of kg. Now come to the point. So G is equal to F is Newton, R measures in meter, so divided by masses of the two bodies will be measured in terms of kg in yes. So two masses are there, I will take it as a 2. So I will write with the value 10 to the power minus 11 Newton meter square. It will come up with a kg per square. This is in terms of SI unit. Now, what will be the unit in CGS system? In CGS system. So, force will be measured in terms of dyne. So, distance will be measured in terms of centimeter and masses will be measured in terms of grams. Now, what will be the unit? Gravitational constant unit. So, I will write it here once again. F r square divided by m1 and m2. So, force will be measured in terms of dyne here. R square will be measured in terms of centimeters. So, kg will be measured in terms of grams. Directly I am writing here g raised to minus 2. This is the unit. So, with the value, what will be the value? 7 into 10 to the power minus 8 centimeter square per gram square. This is the SI system unit of gravitational constant here. Now can we able to find out again the dimensional formula for this gravitational constant? This is very important as per the examination point of view. They may ask for 1 marks, directly you can write the dimensional formula, or they may ask for 2 marks. Now with the help of Newton's law of gravitation, force is directly proportional to the m1, product of their masses m1 and m2, and inversely proportional to the square of the distance between them. So dimensional formula. Dimensional formula for gravitational constant. Now again, F is equal to G m1 m2 by r square. So G is equal to F r square divided by m1 m2. So what is F here? Force. So in dimensional formula, what you will do? Mass into acceleration. M is there. Acceleration L is to minus 2. R will be taken it as what? L square. After you take L square. Then M1 and M2 will cancel as a M and L. Now find out. F is what? M. L raised to minus 2. Force it is. R square means it is a L square. M and take it here. M and M. So 1 M will get cancelled here. What is remain? M. So it is in numerator. So M raised to minus 1, L square, and L is there here. L raised to T and T raised to minus 2. So this is the dimensional formula for gravitational constant. So you need to judge here how to write the dimensional formula. L raised to T and T raised to minus 2. If they ask for 1 marks, directly you can able to write it here. If they ask for 2 marks, then with the help of Newton's law of gravitation, you can free. You will get the judgment clear. Step by step, we will get to know that what we have to consider and what we will get it as a dimensional formula for gravitational constant. Now, next very important part. So now, unit masses of gravitational constant. If you consider the 2 masses or 2 bodies whose masses will be taken it as a unit masses is 1. Though these 2 bodies will be kept a certain distance 1 meter apart. Then what kind of how the gravitational force is executed or how the forces will be taking place. Now gravitational force or the force of attraction is between 2 bodies whose masses are unit and those are kept 1 meter or a unit distance apart from each other. Then again, force of attraction or gravitational force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Then F is equal to G m1 and m2 by r square. Now you know the value of considered 2 bodies masses. m1 is equal to unit, m2 is equal to unit, and these 2 unit masses kept a certain unit distance apart. Then gravitational force between these 2 unit masses, what will be the value you will get? So F is equal to G, m1 is a 1, m2 is 1, again 1 square will be 1. So F is equal to G. What it indicates? The force of attraction between the unit masses is equal to the universal gravitational force between these 2 unit masses when they are kept a unit distance apart from each other. So that value will be equal to, so that force of attraction or a gravitational force F is directly equal to the universal gravitational constant, that is 6.67 into 10 to the power minus 11 Newton. Here you may ask here why it is Newton meter square per kg square. No, it is not, because we have considered the two unit masses here. They are separated by unit distance apart from each other. For these two bodies, the gravitational force is taking place. Again, with the help of Newton's law of gravitation only, the forces are directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Then F, the force of attraction between unit masses, will be equal to the universal gravitational force or universal gravitational constant G. Just now we have calculated with the experimentally, means experimental determination of gravitational constant. It's not studied. That value is what? 6.67. This is presently accepted throughout the universe, and this value, gravitational constant value will be remains constant or remains the same throughout the universe by knowing the values. That is the angle of twist. I mean angle of twist, torque per unit twist, length of the bar, and the masses of the considered two bodies. By knowing all those values, we can able to find out the gravitational constant that we did just now. With the unit masses, what will be the force of attraction between them? So, force of attraction between the unit masses, when they have kept a one unit distance apart from it, that will be equal to gravitational constant, that is gravitational force. So F is in Newton. So 6.67 into 10 to the power minus 11 Newton meters. So this is about the gravitational constant and gravitational force. Gravitational force is a very attractive in nature. In nature, it will attract the bodies, and it is totally independent on the size of the bodies, independent on the medium of bodies between them, and independent of nature it is. So that is a very important or evidence of the gravitational force. And with the help of this Newton's law of gravitation, we can have plenty of applications. So rotation of earth around the sun and rotation of moon around the earth, prediction of orbitals and time periods of the modern artificial satellites, and study or prediction of solar eclipse and lunar eclipse. These all will be made on the basis of Newton's law of gravitation. So this is very much important concept, gravitation, and very much important role gravitational force in the universe. Being the weakest force among the all four fundamental forces in the nature, it will play a very important role, and it will give the most evidence. With the help of this Newton's law of gravitation, we can able to study the time period of the modern satellites and the orbits of it, and many more things on the basis of Newton's law of gravitation. Now, one more thing is that gravitational force or gravitational constant is a scalar quantity. With the help of vector form of gravitational force or a vector form of Newton's law of gravitation, we can understand how the gravitational force is equal in magnitude and opposite in direction. With the help of position vector, we will study now. Now, to understand the gravitational force is attractive in nature, with the help of this vector form of Newton's law of gravitation. So just now I said gravitation force is a scalar quantity. Then how we can study the vector form of Newton's law of gravitation? No. With the help of position vector, so we can able to understand how the gravitational force is attractive in nature. Now look at here. As per Newton's law of gravitation, every body in the universe attracts every other body. So we have considered here two bodies whose masses are m1 and m2. They have kept a certain distance apart here. Now most important thing is how the force of attraction is taking place between the two bodies. Means from the center of the bodies, force of attraction is taking place. So that's why gravitational force is also called as a central force. Now, not only the first body execute the attraction force. Not only the second body executes the attraction force. No. Both the bodies will be in the attraction force. Means first body, consider body A, exerts the force by the second body. Similarly, second body, body B, exerts the force by the first body. So, force of attraction or gravitational force between two bodies will take place equal in magnitude but opposite in direction. Means force exerted on first body by the second body will be in one direction, and force exerted on second body by the first body will be exactly opposite to the direction. So they have their different direction. Means both are opposite to each other when force is exerted on those bodies. It's not only by itself, it's by the others. Means one body attracts by the other body. So force exerted on this body just because or due to or by the second body. And second body exerts the force, get the force by the first body. So we'll write it in the form of vector. So force exerted on the first body by the second body will be in this form. Then force exerted on second body by the first body. So both are opposite to the direction. But force are executing. They are having equal force of attraction, but they are opposite to each other. Now that we are going to study very detailedly here. To understand this, we need to understand the position vector here. Now take a bodies in a plane, xy plane. Consider here a body A is there, consider here a body B is there. So line segment, so representation. So OA will represent the R1, vector R1 here. Now OB, the line segment OB, that will represent the vector 2 here, R2. So they have certain distance, that is R. Okay. Now if we consider this is one body, this is another body, body A and body B. Here the body executes, first body exerts the force by the second body F1 2 vector. Means second body means body B exerts the force by the first body. Force exerts on first body by the second body. Force exerts on second body by the first body. So R1 and R2 will be the position vector of R. The R is what? Distance between the bodies here. Now, how we can write? The force exerted on first body by the second body with the help of Newton's law of gravitation is directly proportional to the M1, M2 and R square is there here. Distance between them. Product of their masses and inversely proportional to the square of the distance between them. Look at here. The force exerted on first body by the second body. Now, force exerted on first body by the second body, the position vector. So, it is moving in this direction. Force exerted on first body by the second body. So, it will move R2, 1. Am I getting? So, R2, 1. What is this R? R is a position vector. R is a position vector that will be resolved here. OA will represent, vector OA will represent the R1. So OB will represent the R2. So R2 here. So how it is moving here? R2 to R1 because force exerted on first body by the second body. So it is moving in this direction. Now we need to write it here R2, 1. So unit vector R2, 1. So what is this unit vector? The vector which is having magnitude 1 magnitude meters. So it can be represented in terms of cap, R cap 2, 1 here. So R will be, unit vector will be magnitude of body by the first body it is. That is equal to the magnitude of R21. The force exerted on first body by the second body it is. So look at it. The force exerted on first body by the second body, it is moving in this direction. R21. So how it is? R21. So we will write it here. So magnitude of R21. Similarly, force exerted on second body, that is equal to G M1 M2 by magnitude of what it is? The force exerted on second body by the first body. So R12 it is. Force exerted on second body by the first body. So it is moving on R2. R12 it is. Now R12. So the whole square and R12 cap unit vector it is, whose magnitude is unit. Clear? Now concentrate here the force of attraction between the two bodies. So force exerted on first body by the second body, that is equal to the G M1 M2 by R21 whole square and R cap of 21. So here negative sign will come. Why? Means the force which is exerted on first body by the second body, that is equal in magnitude as the force exerted on second body by the first body. But that force is opposite in direction of force exerted on second body. The force which is developed or which is exerted on first body by the second body, suppose if it is in direction, in this direction or in this direction, that is opposite to the force exerted on second body by the first body it is. So it negative sign comes here. Negative sign indicates here gravitational force is attractive in nature. Negative sign indicates here gravitational force between the bodies is always attracting in nature. And second thing here, negative sign indicates that force exerted on each body will be opposite to the force exerted on another body. So it is direction. Similarly, the force exerted on second body by the first body is also negative, opposite to that direction. As we know here position vector here. So R12 cap unit vector R12 cap is equal to R negative of R21 in place of R12. So we can place here minus of R21. That will cancels the negative sign here for the force exerted on second body by the first body. We know here R is equal to the magnitude of 1, 2 by the force exerted on second body by the first body it is. And that is the magnitude of R21 vector. That is magnitude of R21 because of force exerted on first body by the second body it is. That is equal to unit vector, unit position vector here R cap 12 is equal to minus of R21 cap it is. Now we place this. So we know here and we know here R12 is equal to R21 cap. Now what it will happen? The force exerted on second body, that is equal to G M1 M2 by magnitude of R12 vector whole square here, that is R cap 21. So minus minus will get cancels and it remains with the G M1 M2 by R21 vector whole square R cap of 21. Now look at the force exerted on first body by the second body and force exerted on second body by the first body. How it will be? So F that is equal to minus of force vector 1. Now concentrate this form. So minus of F1 means the vector form of Newton's law of gravitation is equal to the Newton's third law of motion. What is that? For every action there is an equal and opposite reaction. So F vector F21, what did it indicate? The force exerted on second body by the first body is equal to negative of force exerted on first body by the second body. For every action there is an opposite and equal reaction as we stated in Newton's law, third law of motion. Similarly the vector form of Newton's law of gravitation holds good here. So this is the very important concept which will tell us how the gravitational force is attractive in nature. That is, force exerted on each of the body. Consider two bodies. Force exerted on first body by the second body is equal to the force exerted on the second body by the first body will be opposite to the each